Yeah.
All right, quiet please, let's get going here. Hey, no lie, today is pretty easy, but it's a lot of stuff all at once. It is definitely easy. But it's a lot of stuff. The kid that takes great notes and pays attention, you're gonna get first time, and I'm not lying. It's like first time you get this. I already told you we're past the hard stuff, right? This chapter kind of ends on an easy note. It's kind of more medium, that first thing that we did, clearing the fraction, but it definitely ends on easy. We're gonna do today just one day, and then we're gonna do scientific notation for 2 days. It's really important because of a science class, because of all the science that you do for chemistry and for doing really small things, and for physics, dealing with large things, that you have a firm understanding of scientific notation. All right, any questions on that percent problems that we had? Because this class is rather lengthy, and it's only lengthy because there's just a lot of stuff. Well, of course that makes sense. But sometimes if something's very lengthy, I'll break it up into 2 class periods. This is just easy stuff. It's just you gotta pay attention, write the stuff down, and be fine. Any questions on the percent problems? All right, so Tristan's coming around to grab this.
And pass out the.
No, you're collecting.
Yeah. Can
Rowan.
Brandy pass out?
No, me.
Pass it on.
Brandy's never gotten a pass
I
out.
actually promised before. All right.
I don't know who you talking to like that.
All right, everyone else, listen up. Okay, and you guys that are, I ask you to do it quietly. So here's our calendar. I usually don't do 2 practice days ever before a test semester final. Because of the clearing fraction thing, and I think it's really within our grasp. We've done a pretty good job, chapter 7 so far. And for most of you, you got a really good shot at getting a very good grade on this chapter test. We're going to do 2 practice tests instead of 1. So we're going to have 2 solid days of a practice test. I will be not upset, but I will be angry in the sense of like detention angry if we don't use we do 2 practice days and we don't use it. If it turns into nothing but a talk fest, you will do it in complete silence all by yourself. But I do want to give ourselves the opportunity, the biggest opportunity to do well. Chapter 6, you're like, well, why did you do that for chapter 6? Well, in some ways, chapter 6 is, for some of you, like a bridge too far. It's some really challenging stuff. I never did in my algebra class what you guys did in chapter 6. That was more algebra 2 stuff in pre-calculus or trig.
This is so easy.
I have an extra. Who wants another one?
Agreed.
Why are we? Why?
Because right now people don't know what to do.
This one.
Oh, we're doing.
I always have an extra. All right. So with that out of the way, here's your homework. Write this down, please. It's page 333. It's 2 through 28 evens. This is really, 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 really rule intensive. Right?
What did I miss? 7.9 already.
So we have skipped between 7.5 and 7.9, 7.6, 7.7, 7.8. For a non-honors class, I do not teach those sections. For an honors class, I will teach that. For a non-honors class, it deals with mixtures, and it's some material that is not required. It's not a state standard. It's not anything that's you will be missing in knowledge-wise. If you go on to calculus, you'll see all that stuff again. It's not calculus level stuff, but mixture problems it's not required for Algebra 1. So I choose not to teach that to a non-honors class. If you really like, you just screwed me out of my education. I want 7.6, 7.7, 7.8. See me during student advisement. I'd love to teach it to you. Okay. But for the rest of us, we're moving on to the Algebra 1 stuff, which is today. Our book is kind of weird. I've said it before, it kind of jumps around. We did all the rules for exponents except this one. And it doesn't even fit well into this chapter at all. So the first year I taught this, I threw it at the end of whenever we did exponents before chapter 4, I believe it was. And so I did that, and then the kids complained about, why are we jumping to chapter 7? So last year I just did it in order like this one, and it worked out fine. So I'm going to stick to that. The benefit is that we get an extra day of practice with exponents, rather than we have one section on exponents and we don't hear it again until, the next time we use exponents. Okay, so negative exponents. If you remember, we have not seen negative numbers and exponents before. Today's that day. All right. Oh, this is a lot of objectives. Each one is pretty simple, right? But there's a lot of them. That's why I said today's a lot of stuff to do. So here we go. Here we go. Going back to our basic idea of exponents, we call I don't mean like the big number as 4 is bigger than 3. I mean literally the big number. The bottom number is called and the top number is called or power, either one. So we've already had that before. We use exponents as a way of showing repeated, not addition, that's multiplication, but repeated multiplication. Okay, and we've done that before. So 4 to the 3rd power, multiply 4 3 times, and not 4 times 3, but we get 64. We've seen that before. So write this down, please. Box 1A. Well, 2 to the 4th is not 2 times 4. It's 2 written 4 times, with multiplication symbols between. 2 times 2 times 2 times 2. We haven't done negative exponents.
We did that last year.
We didn't do negative exponents.
Yes, we did.
Yes, we did.
No.
We had to.
What's 4 to the negative 3? What's the answer?
Negative.
Last year we did that, but we didn't do that. And we're going to do both of these today. Okay. So 2 to the 4th is somebody?
16.
Okay, 16. All right. How about parentheses, negative 2 to the 3rd power? Okay, well, if this is write the base 4 times, then what does it tell me to do? What's the base this time? No, it's not. No, it's not.
I don't know.
2.
If the base is 2, then the base is parentheses negative 2. So if I write that, how many times? And do that multiplication, I get.
You're so smart.
For what reason? For why?
Because that's the rule of exponents. It says take the base and write it that many times.
I don't feel like it's a difference. It doesn't make a difference.
What's the answer?
The answer.
What's the answer?
I don't know. I don't know.
Hey, Rome, what's the answer? Okay. So wait a minute. One time you get a negative and one time you get a positive. Why?
Oh.
Because there's an even amount of negatives.
Okay, that's the first smart thing you said today so far, Rowan. Good. Rowan, and that's actually, we'll call it the Rowan rule. Rowan noticed that, say it again, Rowan, it was good. Okay, you can get that from only looking at the power. And if the power is, say it, even, then the answer is always, and if the power is, then the answer is always, write that down in yellow. If it looks like this, now I put variables, notice it's got parentheses. Do you see it? Rowan said it's not going to make a difference. He's going to find out he's wrong. If it has parentheses, there ends up being 2 things that can happen. The answer is going to be negative if the power is odd, but the answer is going to be positive if the power is even, for exactly what Rowan said. That part was correct. It was it doesn't make a difference part that's incorrect. You'll see here in a second. So how can you use this to make your life easy? Well, you don't need to worry about whether the answer's because, by the way, does anybody actually do this?
No.
Nobody writes this out. That's crazy. They say 2 times 2 times 2 is 8. And they say, oh, if it's odd, then the answer is negative. If it's even, it's positive. Nobody ever actually writes that out. Now, I do want to make a huge point here. This is the rule for if you have parentheses, yes? The rule for without parentheses is not this. If you do not have parentheses, it's a different rule. But if you have parentheses and you have a negative on the inside, if it's positive, the answer is always positive, right? If this negative wasn't here, you never get a negative answer. But if the negative is there and you have parentheses, you look at the power. If it's odd, negative. If it's even, positive. We okay with that? Okay. Box 1B is going to be the other rule. So the other rule is no parentheses. What does this say?
Negative 2 to the
Negative 2 to the third.
Well, what does it say now?
5 minus 2.
Wait, is it negative or is it minus?
minus.
So you're saying that changes it?
Yes.
You can't change it.
We can.
It's
You're a
there.
mathematician.
It's either a negative or it's a minus. Which one is it?
Minus.
Minus.
No, it's minus there. The right way
And the answer is that couldn't change because
That's
it's
negative.
this is by itself. It's either one or the other or it's both. Guess what the real answer is?
Oh.
It's both.
Yeah.
It's either negative 2
or it's 5.
or it's minus 2 to the third power. It's either one. And the fact that we say it can be, because clearly it can be a minus now, we get a different rule. So we have a rule for with parentheses, you just wrote it down. Here's the rule without parentheses. Because I can interpret that as minus, I've got exponents, which is repeated multiplication, and I got a minus. Which one do we do first? Do we do minus or do we do exponents?
Exponents. We go exponents.
It's subtract number.
So it's subtract 2 to the third. Well, what's 2 to the third?
Like
6.
So it's subtract 8.
So it's always
Odd. Even.
It's gonna always be negative.
So it's subtract.
Minus 4.
So it, go ahead, Rowan.
Always gonna be negative.
So different rule than with parentheses. So that's what we're going to write. Hey, if there's parentheses, it could be positive, it could be negative. If there's no parentheses, here's the rule. If there's no parentheses, it's always negative. So it does make a difference. It makes a difference whether you have parentheses or not parentheses. With parentheses, could be either one, depends upon the power. Without parentheses, the answer is always, always, always negative. There's your first, okay, welcome to negatives. We did not do that last
I
time.
wrote wrong. I don't know why. Our answer is always wrong. Wrong. So then negative.
All right, write this down, please. Okay? Tonight for homework, they're going to give you a number. It may be in parentheses, it may not be. It may be positive, may be negative. You just got to simplify the answer. So the first part of homework's pretty easy. It's going to be one of these two rules. If you can remember it quickly, great. If not, it's in your notes. Hey, any negatives? It's got to be positive then. What's 2 to the 5th? Fingers, right? 5 fingers. 2 times 2?
4.
It's 32.
10.
No.
4?
8.
16.
16.
32.
32.
Okay. There's a negative, with or without parentheses.
Without, so it's always in negative.
Always negative. What's 3 to the 3rd? So it's got to be.
Negative.
See what I'm doing? Hey, parentheses. It could be negative, could be positive, odd or even. So the answer is, and we already said 3 to the 3rd is 27, so negative 27. You see what I'm doing?
So odd is bad.
Parentheses.
10,000.
Okay. Hey, even. So the answer is
10,000.
positive, right? So 10,000. 1 with 4 zeros. You guys remember the rule for 10 to a power? Right. 1 with 4 zeros. 0.4.
0.0.
This is the one that you better do this one by hand. Otherwise, you're going to screw this up come test day. All I got to do is put a decimal and people lose their brain. This is 0.4 times 0.4 times 0.4. Okay. People get an impression like it's, oh, it must be this. Just please do the math for that one.
Oh, so you get the answer and then you move it 2 places to the left?
How about you do 0.4 times 0.4 times 0.4 and try not to overthink this one. I'm saying this is for everyone, not Tristan. Just do the math.
Think a lot.
How do you multiply decimal?
Me too.
Like normal.
Multiply and then you count how many decimal places to move it over. All right. Answer positive or negative.
Negative.
And then we just got to worry about what 5 to the 4th is. 5 times
Wait, I
5
read
is
that right. It's
25. Times 5 is 125. Times another 5 is. Since some of you will do this, and I know you will do this, calculator. Oh, you try to do this with your I am not encouraging you to do it with your calculator. Right? You can't type this in as minus, look clear, minus 5 to the 4th. It will tell you error, or in this case it said 0, right? If the negative is the first thing that appears, you got to use this key right here.
Yeah, you gotta do that weird thing.
All right. All right. But please don't use calculator. You don't need it. Hey, that's one of a whole bunch of things. Here we go. Next thing. Follow the pattern. How many 4s did I write?
4.
Yeah, because of this 4. How many 4s am I going to write?
3.
How many 4s am I going to
2.
write? You see the pattern I'm doing?
Yep.
What's the next one I'm going to write?
4.
So how many 4s am I going to write?
1.
Well, then what would be the next one?
4.
That would be right 0 4s, right? If you follow the pattern, that ain't the pattern, right? Because otherwise we'd write 0. How do you write 0 4s? This is the pattern. What's going on?
Well, you just put a 1.
This is we're dividing by 4. So the next two things we're going to talk about, well, what would happen if we continue the pattern? What is 4 to the 0? And what is, well, if we continue the pattern, we get into negative numbers. So the question is what happens? That's the next part of the class. Okay? Some of you already know one of those, but you don't know the other one. All right, so today's the majority of the class is on these two patterns right here. Okay? So let's explore those. All right. We did this one, right? How many 4s on top? How many on the bottom?
7.
So if you did it the way we did it before, oh, good Lord. How many would cancel?
7.
And we'd be left with 2 on the top, right? So the final answer is, which is 16. Okay? You see the rule? 9 minus 7 is 2. So there's a rule, right? And we did do this before. The rule for when you're dividing exponents and the bases are the same, top minus bottom. That's it. Okay. So box 3. Well, what's anything divided by itself? What's anything divided by itself? 1, right? So I already know what this is. I could expand it and I get 1. But if we use the previous rule, same basis, what are we supposed to do with the exponents? No. What's the previous rule just say? What did the previous rule say to do with the exponents? Says subtract them, right?
Why do we?
Well, that's what happens when you cancel. I'm going to cancel 7 of them. In other words, 9 minus 7. Okay? So the rule for when you have common bases is you take the 2 exponents, you subtract them. Okay. Well, I already know the answer was 1. But if we follow this rule, what's 2 minus 2?
0.
So we know that anything to the 0 power must be,
1.
it's got to be
0. 1.
We just already did this. Anything divided by itself is 1.
But 4 times.
Well, but if we follow the previous rule, when we subtract the exponents, 2 minus 2, we get 0. So it turns out that anything to the 0 power
There's 0 4s though.
is 1.
But it's 4, it's not 1.
So here's the first thing you got to wrap your head around, is that anything to this, with one exception, anything to the 0 power is the number 1. If you see something to the 0 power, it's 1. Okay? Which is why my clock says to the 0 power. Because right now it is
2.
with the clock, right now it is 1, 1. 2 to the 0. 1, 1. It's 11. Okay?
1140.
So write this down, please. Anything to, that's the exception. Anything to the 0 power is 1 with one exception. A has to be a positive number. Meaning it can't be 0. So A cannot be, next slide says that. I should put it on this one. A cannot be 0 to 0 power is undefined.
So it's 11.
1144.
Yep.
And then don't look at the seconds, they'll drive you nuts. It'll take you too long to figure out. It changes too quickly. All right, we okay with this? Hey, this is the easiest rule and the easiest to screw up. You're like, well, how can you screw this up? If I see anything to the 0 power, I write 1. I don't know why people screw it up. On the test, I will put things to the 0 power, and I'll have kids say, I don't know what to do. If it's to the 0 power, the answer is 1. If it's to the 0 power, the answer is 1. All right, with one exception, and that is 0. We say 0 to the 0 power is undefined. Okay? You start with a 0, you do repeated multiplication, there's no way you get a 1 out of that. What is anything to the 0 power?
1.
What's the answer?
1.
What's the answer?
1. No, it's negative.
Oh no. What's the rule for parentheses?
Oh, yeah, never mind.
If it's in parentheses, we look at the power and see if it's odd or even, 0, odd or even. So therefore it's positive 1. However,
That's negative 1.
that one's negative 1. Why?
Because they don't have
There's no parentheses. And anything with no parentheses and negative is negative. Okay. I had some other ones there. Only one I wanted to show you, the ones with the 0 power for box 4. Hey, you got to ask questions. I said today would be easy, but I'll have kids that get lost on this occasionally. We good? All right. Moving on. Yes. Sure. When you go to college and you do a degree in things that are geeky and whatnot, then you do geeky things. And binary clocks are geeky things. So
where'd you get it?
where did I get it? A store that sells geeky things.
What store is it?
It's probably like geekythings.com.
That's a copy.
All right.
That's a copy.
All right. Hey, once again, negatives on the inside. If B is even, the answer is
even. I mean,
positive. And if B is odd, then the answer is negative. Okay. So we're going to say, and this is kind of a culmination, write this down, please. I don't know what the answer is. It depends upon what the exponent is. Like I truly don't know. It could be negative, it could be positive. It depends upon the exponent. Rowan, write this down.
Are we having lunch in here?
Yes.
Don't leave the room a mess, because he's.
What's the answer? What's the answer?
Minus.
It's always negative. Riley, you're supposed to be writing this down. What's the answer?
I don't know. Negative. Negative.
Who's going to make the argument that it's negative? Why would it be negative, Rowan?
Because the negative's on the outside.
Negative's on the outside. All right, what would be the hardest one?
All of them.
There's all of them.
Oh my gosh.
So what's the answer? Negative or positive?
It depends on the exponent, right? No, because it's going to be negative.
Depends on the exponent. There could be cases, right, where you would get a negative here, and a negative times a negative would be a positive. There's other cases where that could be a positive. Positive times a negative is a negative. So here's everything. Everything. I will tell you, it's an easy concept, but if I want to have kids make a mistake, all I do is put parentheses and throw in negatives, and people lose their minds. I will sit there in this class every year. I'll show this, and I'll have kids same thing just happened. People figure it out very quickly. Somehow this doesn't stick with you. So we get to test day. Make sure this slide right here is on your resource card. It'll keep you straight. Like, oh, okay, yeah, I know the answer's, this or that. Okay, we good? All right. Do you remember doing this?
oh gosh.
No.
What is it? 2 times 2 and then.
Well, this just says write what the base is twice. What's the base?
2/5.
So I write 2/5 twice and multiply.
Oh, that's easy.
Okay, so the final answer is?
Wait,
Can we do the next box on our own, please?
Say again?
wouldn't it just be the exponent multiplied?
So she said it's kind of got a distributive property flavor, right? If we wanted to, this is kind of extra work. If we wanted to, we throw it here and throw it there and multiply.
That's what I would prefer to do.
Okay, that's fine. Some people are like, I'd rather do that than write the fraction twice. Okay? Everybody catch that? That'll work. You do have to reduce the fraction if necessary. Aiden, is the answer going to be positive or negative?
It's going to be positive. No, negative.
Why negative? You're right. It is negative.
Yeah.
Why?
Because it's an even number.
That's for when the negative's on the inside.
Then
When the
it's
negative is
the
on the
opposite
outside,
side.
always negative. Okay, so what's the answer?
That thing, but
Oh, by the way, it's the same thing. So it's,
negative.
I don't even need to do that work, right?
Yeah.
Chris? Negative, positive. Why is it negative?
No, wait, no, it's not negative. It's
Why is it positive?
positive because of the two evens.
Okay, and the negative's on the inside. Because look, it's the same problem, right? But on this one, the negative was on the outside. This one, the negative's on the inside. When it's on the inside, odd, even. Outside, always negative. So you said this one's going to be. So therefore, the answer is. By the way, it's the same problem. There you go. If you have that rule down, these are not hard at all. Tristan, what's the answer?
1.
Anything to the 0 other than 0 is 1. There's no work involved.
I shout out Rowan for that answer.
Hey, I will go ahead and tell you the last question on the test, or one of the last questions.
Wait, really?
I will put the ugliest looking thing ever, and I will put it to the 0 power. And guess what will happen?
I will start crying.
I will take pictures of the fools that actually do the calculation.
I will start crying.
Right. I'm gonna have this big honking fraction with lots of stuff going on the inside, and I'll put parentheses around it to the 0 power. And I will get at least 3 people in this class that will try to do the work. And then the other people will say, oh, it's to the 0 power, the answer is 1. I'm telling you, it's going to be on the test. Be looking for it. All right. Do we need to do this?
12 over 18, I think. I don't know.
Yes or no?
No.
8 over 27.
I was so close.
8 over 27?
1. 27 over 8.
27 over 8? 16. Not 4 times 2.
That's positive.
This one's going to be positive, and this one's going to be,
1.
So it's 2 over 25 and then 1 over 1.
who said 2 over 25?
Yeah.
1 to the second power is 1 times 1, not 1 times 2. Yes? Hey, don't lie to yourself and say, I don't know, he's going fast. It's going to be a quick class, right? If you don't get this, you're going to ask a question. Rowan.
I don't get to talk right now.
3 written how many times?
3 times.
3 times 3
9.
times another third.
27.
4 times 4. There you go. All right, 2 left. Obviously, I'm speeding up. We've got plenty of time left. We've got 20 minutes left. The rest is, it's not hard. It's just got a lot of stuff going on. Okay? If you handle the previous stuff, this stuff is no big deal. Okay. Hey, what was the rule?
Cancel things.
We could, but what's the rule say? Subtract. So what am I subtracting now?
9 minus 2.
That's not what it says.
7 minus 9.
It's a 7 minus 9.
That's what I
So he said, well, what would happen if we did the canceling thing? Well, 7 on the top. We've already done this one. We just haven't talked about what do we do with negatives. We only talked about this rule, the canceling rule. Yeah, we all figured this out, that after we cancel everything, we're left with 2 on the bottom. So the answer is 1/16, right? What's the rule say to do? No, this is the long way, right? Make this 187 over 219. You're not doing this, right? The easy way is top minus bottom. We're talking about exponents here. 7 minus 9. Well, if you do 7 minus 9, you get. So it turns out that 4 to the negative 2 must be 1 over 4 squared. You tell me what I did. Now, there's the rule. Here's the answer. So what do I do to go from 4 to the negative 2 to this? Visually look at it. Tell me what went on.
You put 1 on the top of it.
I put a 1 on the top,
Took away the negative.
took away the negative, and I put that on the bottom. See what I did?
Yeah.
We got to write that rule down. Yeah. Well, I haven't said anything other than just figure out what the rule is. Now we'll talk about what to do. Okay? So here is what you're going to do. This is box 7. Write this. This is the rule. If After you do the subtraction, you get a negative in the exponent. You're going to take it and move it to the bottom, make it positive, and put a 1 on the top. You see the negative? Do you see a negative?
No.
So I got rid of the negative, and it's over 1. What negative exponents do is it makes it flip positions, because watch this. You see what happened? It takes the thing, it flips it, and it makes the exponent positive. Haley. Takes it, flips it, makes it positive.
But then it flips it again.
It can, if there's parentheses. All right. The more general rule, the one that I really want you to remember is this one. Okay? You see this? If you have negative exponents, you take the whole thing and it moves position. This will now live on the, and this will now live on the, so they basically flip positions. Now here's where it gets complicated. This only occurs when,
They're both negative.
when you have a negative. If you have a positive, it doesn't move. It stays. So on the top it stays. On the bottom it stays. I'm going to say that again. This movement only happens when there's a negative exponent. You got a positive exponent, you don't do anything. You leave it there. You can kind of see where we're going with this. Sometimes you have positives, sometimes you have negatives. The only one that moves are the negative ones. The negative ones move position. And secondly, when you move it, you get rid of the negative. Okay? Most kids kind of like, okay, I kind of see where they're doing this. Until we do some examples, it doesn't really stick with you. As soon as we do some examples, I get plenty of kids who are like, oh, this is really easy. And it is, but you got to do the examples. So Rylan, make sure you guys are doing the examples. You ready? You good? All right, let's see some examples. Hey, we got a negative exponent, so what does it make me do? And remember, this is really over 1.
You flip it.
So all it does is that 3 to the negative 2 moves to the bottom. Negative goes away, and 3 squared is 3 squared is.
Like mine.
There you go. Now, yes, we're going to combine the previous rules with this one. First off, is the answer going to be positive or negative? How do you know? Because 3 is even, right? So it's actually going to be, negative, right? With the negatives on the inside, odd or even, right? If it's odd, it's negative. It's odd, so it's negative. It's even and it's positive, okay? Hey, but we got a negative exponent, so that means it lives on the bottom. Now, they're never going to write it like this. They're going to put the negative in the middle. Okay? Would I mark this wrong? Heck no, I'd be happy you got that answer.
You would?
I would be. Yes. When you move it, it loses its negative. Okay? We okay?
No.
All right. Here comes a complicated one. Rylan, what are we doing? Okay, so tell me what to write. You just said flip it. Flip it.
Okay, then you write 4 over 3.
4 is not to the 3rd power.
It's 4 the negative 2nd power. Over
When you flip it, what happens to the negatives, Kaylee?
Negatives go away.
Rylan, finish it.
Oh, something that is 4 to the 2nd over 3 to the 3rd.
Okay, Rylan, come on, you can do this. Right? All you do is flip the things that are negative. Now be careful. I don't want you to think it's the, well, in this case, the whole fraction flipped. But what we're really doing is moving the negative exponents. Whatever position they're in, they move. They're on the top, they move the bottom. The bottom move the top. If one of them is positive, because it's going to happen here in a slide or two, It doesn't move. It's only when the things are negative. And by the way, you still need to do 4 squared and 3 to the third. Haley? Yeah? Okay. We got to do these together. We're not blowing these off. Okay. One on the upper left. Hey, we got a negative exponent. Remember, that's really over 1.
So it'd be 1 over 9 to 2.
So that's 1 over 9 squared, which is
81.
1 over 80. Not 81, but 1 over 81. Bottom one. What happens?
2 over 3 over.
Chris, stay with me. Right? This whole thing is going to move to the top and become positive. So that's 2 to the third power, which is 8. And you're like, what happened to 1? Okay, it's still there if you want it, right? We just choose not to write the 1. So that whole thing is 8. Yes? This is the green box. Usually I always just write answers. Okay.
Are you being
No, when somebody on Teams sends a message, then you get that little ding.
Oh.
But are you supposed to be doing?
Kaylee?
No, I mean,
Green means, it's supposed to mean that you work independently. Blue means we work together. Red means you write down definition.
Are you on a Zoom meeting?
Or
Aren't you
meeting.
supposed to be recording this?
Who's not here today?
My Josie.
No one. Haley was the only e-learner ahead.
Michael.
Josie is,
Michael.
oh, that's right.
And Julie.
Julie is technically not an e-learner. She's just sick today. She was supposed to come back today.
Don't forget the mic. And Michael.
She didn't. Michael, I forgot about Michael. All right, over here. Sorry, Michael. What do?
It's 8.
We flip it because both of them are negative. So this goes to the top, this goes to the bottom. Well, that would reduce to not 11, but 2. Okay. All right, here's your first weird one. You ready? I said if it's positive, what do we do with it? It stays where it's at. But this one is negative, so where does this one go? And you make it positive. What's 2 squared? What's 3 squared? You get 4 9s. Hey, some of you aren't paying attention. Here's your first challenging one. We have a combination of negatives and positives. The negatives flip position, positives stay where they're at. So this would be 2 to the second power over 3 to the second power, which is 4 9s. And now they're going to get complicated because we're going to throw variables in. Okay? All right, here we go. What moves? What happens to the 5? What happens to the 8 to the third? So the only thing that moves is the b to the negative 2. So where does it move? And you're technically done. Now I'll show you a complicated way. Well, if we broke this up because it's multiplication, we know that b to the negative 2 is 1 over b squared. Multiply everything straight across, and you get to, oh my word, that's too much work, right? This is the explanation of what works. The reality, guess what people do? From here to there. And no, I'm not saying you have to do this, but this is the math that allows you to do that. Okay? So I'm not claiming I want you to do this, but I am claiming that this justifies that answer right there. Okay. What moves?
The 2x minus 6.
No.
X minus 6.
Just the x minus 6. So it moves to the bottom. You're done. Now, guess what will eventually happen? Eventually, what's going to happen is some things are going to cancel. We're not there right now. Haley? Anything to the negative power moves. Just the things to the negative power. Yes? Okay. Aiden, what moves?
Things to the negative power.
So where does it move? Where is it right now as it's negative?
It's on the bottom.
So where is it going to move to?
To the top.
And you make it positive and you're done. Easy?
Yeah.
Remember I told you today was a lot of stuff, but they're all pretty easy. And I said the kids do well, the kids that pay attention. If you didn't pay attention, this is way too much stuff to figure out by yourself. Nathan, what moves? Okay, so what's the final answer?
Wait, what do you mean? It just moves to the bottom?
It would. So what's the final answer?
Let me make sure.
What's to the negative power? If I ask you
I
to,
can't think right now.
if I ask you to circle what's the negative power, what would I circle?
Then 3, right? Yeah. Or D.
So that's what moves. Everything else stays where it's at. So move it and tell me what's the final answer. If it's on the top, where will?
Okay. Maybe even 3 and D positive. Right?
Yes,
Or
you mean the negative root, right?
Yeah.
So what's the final answer?
3 D to the third.
What happened to the 4?
It stays.
So give me the whole thing. Give me everything. If-
So,
Which ones do we move?
the D.
So all I'm doing is moving that to the bottom, making it positive, and then writing what's left.
4 and over 3 to D third.
Perfect. Okay. Yes?
Yes.
Good job. All right. So that's it. This isn't that complicated. It gets slightly more complicated if there's things we can cancel. So let's look at that, and then we'll stop. All right. Last one. All right. Just remember the 3 rules. All right. When I'm multiplying, what do we do with the exponents?
Ignore them.
Okay. What do we do with the exponents?
Add them.
Okay. If you need to write this down, write this down. When we do a power to a power, what do we do with the exponents?
Multiply.
You need to write this down, write this down. I don't see anyone other than 3 people writing down. That's fine because Randy's got it memorized. And then we just learned that for division, what do you do with the exponents? You subtract. We're going to use all 3 of these rules now. You ready? Remember, you can only do this if the bases are the same. That means you can combine 2's with 2's, x's with x's, z's with z's, but you can't combine a 2 with a z. So let's see how this works. You ready? What's that say? What's this power? So what's the rule for multiplication? -2 plus 1.
And then they just the whole thing is 1.
What's any number divided by itself?
1.
Yes? This is a lot of work. Who said go back a slide? These are the 3 rules we're about to use. Multiplication, you add. Power to power, you multiply. Division, you subtract. And just remember, we will be subtracting with negative numbers. Subtracting negative is adding. All right, we just did that one. Let's do this one. What's that say? So what do we do? -2 plus 5 is? So we get 3 to the third on the top. When you get division, what are we supposed to do with these numbers? So that's 3 minus -4. Do you see that? 3 minus -4. What did 2 negatives turn into? So the final answer is no, they don't want you to do 3 times 3 times 3 that many times. You're like, well, how come I can do 3 to the third, change that to 27? Yeah, it's not a good rule. Yes. Oh, you were going like that.
No,
Okay.
that was
Everybody follow that work? That's a lot of work, Kaylee. You follow it? It was fast. Multiplication means add the 2 numbers. That's -2 plus 5. That's +3. Division is subtract. 3 minus -4. 2 negatives turn into a positive, so 3 to 7. You see the pattern, it's not that big of a deal. Hey, there's another way we can do this. Some people like to do it this way. I'm not one of them. We got a couple rules that we can use. We said that if you ever see a negative exponent, guess what you can do with it? You can flip it. You have negative exponents here and here. If I wanted to, I could flip them if I wanted to. So I flipped them, but then I'm still stuck with the fact that I got to do what? Add or subtract, multiply. 4 plus 5, -2. If you like that method, go for it. Either way works. It's still using the rules. For me, when there's this many negatives running around, I'm going to make a mistake and forget to flip one of them. I'm not saying that this is the better way, right? I'm not saying this is the better way. There's just two different ways of doing it. All right. Hey, power of power. What are we supposed to do? 3 times -2. What Sierra said is this 3 also goes down here. So that's going to give me, so I get 3, I get x to the negative over x to the
12.
-6 is,
6.
-6 minus 12 is, and where do the negatives live? Yes? You want to do it the other way? Where do negatives live? So this would be 1 over x to the, move that to the bottom, 6. Because 2 plus 4 is 6. And all of this is to the 3rd power. Well, 1 to the 3rd power is 1, and 6, right, times 3 is 18. You can do it either way. Yes?
What do you do when there's no exponents on the inside, but just -1 on the outside?
Just flip it. She's saying if something's just to the -1, what do you do?
We get out like 5 minutes.
All right. Hey,
Hey,
isn't this what she just asked?
I guess.
2 to the 5th. No.
You said if there's just a negative, what do?
But when there's no exponents on the inside, you still just flip it.
Well, remember there's always an exponent because 2 can be written as 2 to the 1st.
Okay. But when they're not negative.
Me personally, I'm not a flipping kind of person. I'm a multiplying person. So when I see this, I multiply every exponent times -1. Border, do it for me.
Oh, I don't know what that is.
I'm saying, I'm not, we just discussed the fact that we could flip the whole thing. I said, nah, that's fine. I'm just, let's just multiply everything through by -1. And by everything, I don't mean this, I mean the exponents. So multiply all the exponents by -1, what do you get?
Everything.
Keep talking.
-2 and
Okay. So he would have gotten 2 to the 3rd times 2 to the -2 over 2 to the 4th. Okay? And we're done with the -1. 3 plus -2 and 2 to the 4th. And what's the rule? 1 minus 4 is, and where do the negatives live?
You can wait. Just take off this side of it and then hold it like this so your ears aren't.
Well, then I'm standing here like this the whole time.
Well, isn't that way better?
Okay, guys, listen to me.
Do like this.
You don't have to hunchback, you know.
Exaggeration. Now, you're going to see me doing this one. There's lots of different ways to do it. Okay? I'm going to do the inside first. What's -3 plus 2? So what I did? And then I'm going to distribute the -1 to everything on the inside. 1 minus 4.
-3.
And we just said that they live on the bottom. And 2 to the 3rd is 8.
You can just like sit back.
Okay, guys, we're getting out.
I'm not saying that my way was the quickest or easiest. This is kind of my thought
But I'm
process about
saying
how I would do this.
Is there-
No. This is, I'll have kids do it completely a different way. They'll flip it first. Some kids will move okay, now I'll move the negatives first. Watch, we'll still get the same answer. That goes to the bottom, this goes to the top. So we get 2 to the 4th times 2 to the 2nd over, please stop talking. Okay, all to the -1. 4 plus 2 is 6, so we get 2 to the 6th over 2 to the 3rd, all to the -1. 6 minus 3 is 3, so we get 2 to the 3rd to the -1. That times that's -3 lives on the bottom, 1 over 2 to the 3rd. Lots of ways of doing it. It's your choice.
Yes.
We are eating in here. Please do not leave my room a big honking mess.
That's a bad word, sir.
What's the bad word?
Honking.
Honking? That's what geese do.
Nope, bad word. Sorry, sir.
Reporter. So geese are bad.
Which one is the box for homework? I just found it.
Did I collect them?
No.
I made this in your
Thank you. Is this your middle name? Is this your, I personally like the VDH thing. All right, Michael, even though they thought I wasn't recording this, I was recording this. Do you have any questions? Let me know. I was recording this.